plan for... Apparently it wasn't recording. Does that mean it wasn't recording through any of it? Huh. Alright, well, good thing I have those written notes. I think somehow it got bumped and stopped recording. Oh well. So any patterns of nature, they have kind of characteristic sizes or shapes or distances or lengths or time scales that are associated with them, like beach ripples in a beach or sand dunes or any of these, that are related to the underlying physical processes, but it doesn't take much of a disturbance in the original landscape to trigger it, if it's an active process there. Oh, so here it is, the hill slope gradient. This is what I was. So the hill slope gradient here goes from these to this as the hill slope gradient increases. The number of stones in your soil matters. So the fineness of the soil, the number of stones, I don't remember what. See where it is. Do you, Stefan?
I think it was
how
close they were. Yeah, I think that's all that I tried to explain.
Okay.
Yeah.
Cool. Anyway, these are some minor things. Just knowing that there are these processes that interact, that create the stone circles, has like subtle things that will change it. So this is just a model, that model of the development, which I think is a cool model. But some of the other big, I think this might be my last slide. Pingos. Have any of you guys seen? There's a pingo here in Fairbanks, out on the west side of town. There's multiple of them. There's one out.
So Pingo down that way as well.
Is there one that way as well? I don't know. The one I've heard about is out that way, past Rosie Creek Farm area. But they form basically by that same process, but over just a bigger scale. You're sucking in moisture from the sides, often here, as well as from underneath, but often from the sides. You don't get pingos in areas that don't have much permafrost. They're really just in permafrosty areas. And so it's more the lateral sucking of the moisture that creates a big ice lens inside. Although I think there's still arguments as to whether all of them end up with a nice big ice lens or what they really look like inside. But they do end up creating their own little microclimates. I have one friend who was studying the changes in vegetation around pingos, because there's different amounts of moisture and different aspects to the sun, even on these features that are only a few meters high and maybe tens to hundreds of meters across. So I think that's my last. Oh, here's degradation. So we're starting to lose it. There's a good one. Oh, this is here. This is back behind the GI is off there, and this is the WERB building, the back of their parking lot. And so they basically, I don't think that they realized it was there when they put the parking lot in, but then the existence of the parking lot changed the thermal environment and caused it to melt. And so that's why around here you have to be very careful to either plan to keep the ground frozen, which means building your house up on stilts so that you can have cold air underneath it, or making sure there's nothing underneath it like this, or digging that out and then backfilling it with gravel or something, which is what some people do to try to build a house foundation. It's hard to know if that's going to be there, though. I mean, you could use ground penetrating radar to find it, but most people can't afford to get a company to to do radar on their new house property. In this same deal, this is up in Barrow, but all of this ice underneath here, as it melts out, the whole landscape loses its structural stability. So it's much more susceptible to storms and waves. That's it. So, Thursday, we're digging into some glacier stuff. I do want to come back and review some of that sea ice stuff that Frankie talked about. We won't forget to do that. But Thursday, we will be doing our glacier flubber experiment.
Flubber.
Glacier races.
Can I have your sign this?
Yeah.
Thank you.
Thank you guys, and nice job today. You all did a good job.
So yeah, 3 rows.
Oh.
So that's why. And yeah, I got to place the.
So this is for next semester. Isn't there a form that says for the fall? As opposed to just adding a drop? I mean, I guess there's one that's normally like beginning of semester.
Yes, that's what I did last semester, and I couldn't find it.
I know, right? I don't blame you.
If it doesn't, you
I
can
got
just
a lot of work to work on.
And the space for your information. Do you have a 6 hours? Oh, I saw it.
Grad students don't sign up until September or August.
No, for the 400 levels.
Right.
Oh, that's
You
the-
know, I don't have time to go back. I got so much other
So are there should be, yeah, there's gonna be a few, there's probably gonna be 3 or 4.
Okay.
How are you doing in your class?
Frankie's gonna be in it. Amanda's already taken it.
What?
Foundation of
Last 10 minutes?
I think of who else. I know Frankie and Joshua will take it.
They working with you though?
There's probably a couple.
I think that Jeremy
Jeremy
has to take it.
has to take it.
Yeah.
Okay.
It's real fast. Just gonna do
Yeah.
Let me see.
That's right.
I
The
think.
fight for another day. I was worried about that. Oh, me too. Then I'm not gonna find it anyway. Yeah. Well, I was trying to read between the lines of some of this stuff. It's gotta mean some kind of segregation game. And then it hit me, I was like,
Raph, you did a totally fine job with that.
thanks.
Don't sell yourself short. Fine. It is hard. No, I thought you guys all did a. So of all the things I'm expecting, let me just because everybody's name is up here. So let me just look. These are the things that.
An alternative to the right spot
Yeah.
instead of the 2 other places.
That's all right, yeah. Let's see, that one. Yeah, you turn in a Man Ice Classic, you turn in Making Ice. It looks like everything is here. I have little exclamation points for the things that are there, but I haven't graded yet. So yeah, I don't see any that are missing. I'm expecting.
I think I want to redo the radiation module, but I don't know what to the answer for the writing for the the physics of the energy, like the energy distribution from the sun, and because you only explain that like a little part of it, not like
So there's 2 options for that. Some of that is in the book. Those are pretty standard numbers for the energy from the sun.
Oh yes.
They're very relatively well-known numbers. You could probably find some of that.
Oh.
Well, and some of it you don't. You want to know what the answers are so you can check
Like-
your math.
Well, there is no really formula to calculate that, like
I gave you all the.
yes.
So sigma t to the fourth.
So that formula will be used for all of them?
Well, that's how you get the
'Cause-
total heat from the sun.
Yeah, that's the total heat.
And then you use that either.
Yeah.
So you have the total heat from the sun.
And divide it.
You divide it by the
6
area
pi.
that it's spread over, and then you have to think about it getting some of it being reflected.
Yeah.
So the albedo comes in there. And then you have to go do it in reverse. So at one point you know the temperature and you calculate the energy.
Mm-hmm.
And then
Okay.
the next time you use that equation, you have the energy and you go backwards and you calculate the temperature.
Mm.
And that's how you get the temperature of the Earth.
Yes.
Right? So you have
The
the energy
surface,
from the
right?
sun, and
Yes.
then you divide it and make it smaller and make it smaller and make it smaller, and then you
Yes.
stick it back into the sigma t to the fourth equation,
Uh-huh.
and you can get the temperature of the Earth.
Yes.
But all of the equations should be in there.
Okay.
And if you can definitely, you're welcome to check your answers against any other students, as long as you write it and go through all of the all of the math
Yeah.
on your own.
So I'm getting a weird number. Very.
So you should end up with about
Yeah.
250 degrees for the temperature of the Earth. 250 degrees Kelvin.
Oh, Kelvin.
Yeah.
Oh, it's in Kelvin.
Yes, it's in Kelvin.
Oh, I see. Oh. Okay.
Alright, see you later, Aaron.
See ya.